going to determine from a graph if the graph is a function and then find its domain and its range. So let's start with function. If I want to decide if something is a function, it needs to pass the vertical line test. The vertical line test simply means you take a vertical line and you move it from left to right, and as long as the graph is only in contact with one point at a time, then it's a function. This curve is made out of a whole bunch of points. So again, we only want to be in contact with one point at a time. So as I move this vertical line, I'm now in contact with the graph at this end point, and I continue being in contact with the graph at just one point at a time. So this is a function. Specifically, it's known as y is a function of x. All right, next for domain. If I were to make a t-chart, let's say like that, and this t-chart contained every point that's on this graph, all of the x values would be the domain. To find and list the domain, you can take that same vertical line and just move it from left to right. Your answers are going to come off of the x-axis. And whenever this line is in contact with the graph, that's the part we want to use. So I'm not in contact with the graph now, but as soon as I get to -3, I'm in contact with the graph. Then I continue moving along, remaining in contact with the graph, and then at +3, I'm still in contact, but just after that, I'm no longer in contact. So our domain is going to be from -3 to 3. In other words, the numbers that we might find here in our x column could be -3, could be +3, but it could also be any number in between those two. As for range, instead of moving a vertical line from left to right, you want to move a horizontal line from bottom to top. We're going bottom to top because we want to list with interval notation from the least to the greatest. But we're going to do the same thing. The only difference is our numbers are going to come off of the y-axis. The first time that I'm in contact with this graph is right here. And the y value is +2. We remain in contact until +5, and then after +5, we lose contact. So our y values, our range, is going to be between 2 and 5. So we're going to have 2 through 5. Similarly, if I made a t-chart that contained every point on this graph, the range are the y values. So the numbers we would find over here in the y column would be any number 2 through 5. Here we have another graph. First, we're going to decide if it's a function. So we're going to perform the vertical line test. As I move this vertical line from left to right, we can see that this vertical line is in contact with the graph at more than one point at the same time. It's in contact down here and up here at the same time. So this is not a function. This, of course, happens multiple times where we're in contact with more than one point at the same time. So it is not a function. I'm going to say no. All right, next, domain and range. So to find domain, remember you want to take a vertical line and run it from left to right. And if you're in contact, then you're looking at the numbers on the x-axis to list out the numbers that would be in the x column of your t-chart. Okay, now as I move from left to right, no matter how far I move this line over, I'm going to be in contact with the graph. because this has an arrow on it and this one here has an arrow. So this graph is going forever to the left. So no matter how far I move, I can't get over far enough. So as far as I can go from the left, that would be known as negative infinity. We are going to remain in contact with the graph until we get right here. And that's at positive 5. After positive 5, we lose contact. So listing the x values from least to greatest, we're going to say negative infinity through 5. The symbols, you always want to use a parenthesis for the infinity or negative infinity, because you can never actually get there. It's a concept, it's not a value you're actually getting to. And then we're going to go up through 5, and we actually are in contact at 5, so we're going to use a bracket. As for range, we want to go with a horizontal line from bottom to top, and we want to see when are we in contact. Well, I can't move this down far enough so that the graph is above it, because this one here is going down and it has an arrow, so it's going down forever. And so it's, no matter how far I move this line, at some point way over there, we're going to be in contact. So from negative infinity, and we remain in contact, and then this arrow is going up forever, so no matter how high I move this horizontal line, we're going to be in contact as well, because the graph is going forever down and forever up. So from negative infinity through positive infinity. Again, parentheses, smallest to largest. So that's our range. Let's start with, is this a function? Moving a vertical line from left to right, we are only in contact with the graph at one point at a time. So yes, y is a function of x. Next, to determine the domain, we're going to again move a vertical line from left to right, because we want the small numbers off the x-axis through the large numbers. And we are in contact with this graph for the first time at -2, numbers coming off the x-axis for domain. So -2, we remain in contact with the graph until we get to not quite 4. All right, that open dot means that at 4 we lose contact. But at 3.999999999, we are still in contact. So the notation just changes a little bit. We are in contact from -2 up through 4, but not including 4. So bracket to say that we are in contact at -2 all the way through 4, but not including 4. So to leave out the 4, you use a parenthesis. All right, we're going to do something similar for the range, although of course we move from bottom to top, smallest to largest, answers coming off of the y-axis. All right, the first time we are in contact is just after -3. At -3, since this is an open dot, we are not in contact. But as soon as our y value is -2.9999999, as many nines as we want, we would be in contact. So we're in contact, not at -3, but just after, and we're in contact until we get to 5. And we are in contact at 5. So our notation is going to be parenthesis to leave out -3, comma, and then we're in contact up through 5. All right, one more time, domain range. Numbers -2 through 4, not including 4, are the numbers that you would find in a t-chart in the x column for all the points on this function here. And range, those are about the y's. All of the numbers I could find in the y column in a t-chart made for all the points on this graph, the numbers in that y column would be not -3, but everything between -3 and 5 and 5. Function? Well, let's take a look. Let's run our vertical line from left to right and see if we're in contact with the graph in more than one spot at the same time. I'm moving it across here and I'm only in contact with the graph at one point at a time. It looks a little crazy here at -2 because we have a solid dot and an open dot, which means that at -2 we are only in contact with the graph up here. Now, just as I move past -2, I'm now on this horizontal line segment hitting one point at a time, and then I lose contact for just a little bit here, and then I'm back in contact, but I'm only in contact with one point at a time. This line, of course, goes forever up and forever down, so we'd be going through here, but we're only in contact with one point at a time, so yes, this is a function. Y is a function of x. Just a little note, if that would have been a solid dot, this would not be a function. If they were both solid dots as I come across, then I would be in contact with 2 points at the same time, making it not a function. On to domain. Let's move from left to right, and we are going to use the numbers off the x-axis to list the numbers that are in our domain. All right, so as I come across, I am not in contact with the graph at -5 because we have an open dot. But as soon as I go a little bit further, we would be in contact. So at -4.999999, yes, we would be in contact. All right, so we are in contact just after -5, and we remain in contact. At -2, we are still in contact. We're in contact up here on that solid dot, even though we're not in contact here. But as soon as we move past -2, we're on this horizontal line, so we're still in contact, and we lose contact right there at 0. So far it is going to be not including -5. We remained in contact, even though it looked kind of crazy. We remained in contact all the way until here. And so that's at, coming off the x-axis, at 0. And at 0, we are in contact, so I'm going to put a bracket. The next time that we are in contact is just after this asymptote. This asymptote is at 1. And so at 1.000001, we would be in contact. We'd be way up high. So just after 1, we become in contact. So we're going to do a parenthesis, 1. And then if I continue moving over here, I'm in contact with the graph until I get to +5, solid dot, we're in contact. So bracket 5. And then we are no longer in contact. We're going to put a U to put those together. That stands for union. All right, so the x values are not including -5 through 0, including 0, union, not including 1, through 5, including 5. On to the range. Bottom to top. We want to go from small to big. So moving this line, this horizontal line from bottom to top, the first time I am in contact with the graph, answers coming off the y-axis, is at -5. I remain in contact, still in contact, and then this arrow is going up forever. So no matter how high I go, I will be in contact with the graph. So the range is going to be -5, including -5, through infinity. So bracket -5 through infinity. And you use a parenthesis for infinity because you never actually get there. It's just a concept. You're not going to include it.